Hi, in this video I'm going to talk to you about homework involving logistic regression and some advice about how to do this homework and what things mean and what you should do. First of all, take a look at the logistic regression homework markdown file. You'll see that there are some packages that you will need. You'll need knitter, ALR4, ggplot2, and resource selection packages. And remember that some of these you probably have already installed and everything's fine, but the package like resource selection you probably have not installed before. And so remember, you'll have to go over to the lower right pane to packages, and you'll have to choose on install, and then you'll have to type in resource selection in here and install that package. So make sure you've done that. Otherwise the markdown file won't work. In the first problem, you are asked to try to explain whether a cow survives or not as a function of the variable myopathy. And myopathy has two levels, present and absent. And so you are going to build a logistic regression model that tries to explain the risk of the outcome variable, which is a survival. The cow lived or the cow died, and you're going to be estimating that model here in model M1, and then you have a summary of that model, summary M1, and you are given the estimated coefficients for the intercept and for the indicator variable for myopathy present. You'll notice the myopathy present variable has a negative number for the coefficient, and that's going to imply that when we transition from absent to present, myopathy absent to myopathy present, you should expect the risk of surviving to decrease. That's what the negative value here would mean. In part A, it says, fit the logistic regression model with myopathy as a predictor of the outcome variable. Address the following issues. Interpret the effect of myopathy on survival. Give a complete discussion as presented in class. So I've started that for you by showing it's a negative number. You probably will want to do something like make an odds ratio out of it and talk about the significance. It says also in markdown line 33, estimate the probability of surviving for both levels of myopathy. And I've done that for you here with this predict command. One of the levels of myopathy has a probability of surviving of 0.385, and the other level of myopathy has probability of surviving of 0.0659, and hopefully you can figure out which ones those are. In part B, it says fit the logistic mean function as a function of myopathy and the log of the CK value. That is going to be some kind of blood chemistry variable that is helpful for understanding the cow's health. And it says to build such a model, and you should add code that will help you do that. And it says myopathy and CK, you might need to add code. I want you to talk about the effects of myopathy and the effects of CK, make odds ratios and confidence intervals, make effect plots, do goodness of fit examination with a Hosmer-Lemshow test as discussed in the notes, use marginal model plots to see if the data mean function is matching what the model says, and then talk about case analysis like residuals, Cook's distance, and things of that nature. And so here is a model that is pretty complex. It has an effect for myopathy, an effect for the log of CK, and an interaction between myopathy and log of CK. And here's the summary for it. Here is a capital A ANOVA table for you to understand the type 2 analysis effects, to decide what effects are significant and what effects are not significant. I've included some effect plots so that you can understand how the risk of survival, outcome survival relates to CK and relates to CK for the different groups, myopathy absent, myopathy present. And I've given a Hosmer-Lemshow test, which you should talk about in your results and use the notes for understanding that. Here are some marginal model plots that I've provided, and that was to get you started. So over here in the Markdown file, I've shown you some of the things that I've provided, but you're going to need some additional things. You might need some commands to make odds ratios. You might want some residuals plots and things like that, so you'll look through the notes for the commands for making those and add those to this code block so that you can discuss them in your homework. In problem 2, we have another homework problem, and the response variable here is whether a student is admitted to graduate school or not. The admit variable is a 1, takes on the value of 1 if the student is admitted to graduate school, and takes on the value of 0 if they are not admitted. And what might be involved in getting admitted is your GRE score. That's an entrance examination for graduate school. And your undergraduate GPA might be important. Better undergraduate students probably have a better probability, higher probability of getting into graduate school if they have better grades. And the prestige of the undergraduate school also matters. And so that's this rank variable. And rank is a category variable, and it takes on value 1 for the highest ranked schools and 4 for the lowest prestige schools. And I've given you a basic model here using GRE, GPA, and rank to try to explain graduate school admission. And what I want you to do is talk about the effects of this model, and so talk about the effect of GRE, talk about the effect of GPA, talk about the effects of rank, use odds ratios to discuss those as we've done in the notes. Here are some effect plots that might help you understand the effects. Here are some plots to sort of see the predicted probability of admission as a function of GRE and the institution's rank, just sort of a helpful plot. To fully understand the goodness of fit of the model and to talk about outliers and residuals and so forth, you're going to need to add some commands. And I've given you an empty code block here in line 132. You can add analysis commands that you need to talk about marginal model plots and residuals, maybe some commands to do odds ratios. That kind of thing will go here in line 132. The final bit of output is a regression tree, which is discussed in the classification tree, which is discussed in the notes. And remember, the way you read this is all of the observations, 400 of them, start out in this node right here, and we split them up into sets that are the most homogeneous about whether the student was admitted or not admitted to graduate school. And the separation, the first separation, is by GPA. Students with a lower GPA are filtered off to the left. GPAs below 3.4. GPAs above 3.4 are filtered off to the right. There's 192 of those. There's 208 of these. And you can see for the high GPA people, 43% of them were admitted. For the lower GPA people, only 22% were admitted. And then further splitting is done on other predictors. And so what you should observe from this classification tree is something fairly similar to what your logistic regression model would tell you about the effects of GPA and GRE and rank, prestige rank of the institution. So use the classification tree to sort of help you understand and explain the logistic regression model that you're going to make in this problem and summarize. So I've given you a start on the commands that you will need, but in order to finish the analysis and properly talk about the effects and odds ratios and goodness of fit, you're going to need to add commands to these code blocks. And I'm expecting you'll be able to use the notes and put them in the appropriate places. Let me know if you have questions.